Hello, fellow leaders of the web. I'm Nathan Tranquilla. I've put some deep thought on the problem of implicit conversion with JavaScript and how TypeScript fails to adequately address this problem. In this video, I will distill my thoughts down to a few key insights and show you how implicit conversion is a thing of the past with next-gen web development languages. Here we go. All right, let's start this conversation about implicit conversion by taking in this example. Here we've got the number 5 and 3. We're clearly trying to add those two together to get 8, but we pass in 5 as a string, and because of implicit conversion, we don't get 8 as the output as a number. We get the string output of 5 and 3 together, 53. So that's clearly not the value that we're looking for. All right, having thus been primed, let's get into the conversation about implicit conversion and why it's undesirable. We've just seen an example that demonstrates a little bit on a gut level why it's undesirable, mainly because it's a source of bugs that are tricky to debug as they propagate their way deep into the code down the call stack. The exact nature of that bug makes it hard to debug, as you have to trace it through the code, and it does not provide clarity to the code that you are trying to debug. All right, let's take a look at this bit of TypeScript code demonstrating this issue with implicit conversion that even TypeScript can't solve using the loose operator. So here we have a function, totally contrived, two parameters a and b being either string number or boolean, and we pass in 5 the string and 5 the number, and these should not be the same, but because of the loose operator that TypeScript allows, we get some implicit conversion, and we get 5 equals 5 is true. And then we have the same issue again with 0 and false due to the coercion inside the function. So this is a scenario. This is a TypeScript. This is a scenario in which TypeScript does not solve the problem of implicit conversion. It's inadequate to solve the problem. You could solve the problem with ESLint, and it would if you required your linter to require strict equals. That might be a conversation or a video for another time, though, as we find ourselves in the JavaScript ecosystem supplementing with libraries what the language appears to lack and what we are telling it should have. Okay, let's jump into another example of implicit conversion, but centered around an API example. So here we have a function fetch price. We've mocked up a function called mock fetch price. This is meant to simulate like a fetch request. We get the data back. We make an assertion that it is of the structural type price, and this compiles. But instead of really failing at runtime, what we get is an implicit conversion that actually makes the debugging process on this difficult. So we fetch the price, we get it, and then we add 10 to it, thinking that we're adding 100 plus 10. But no, we're actually concatenating 100 the string with 10 the number, which gives us 10,010 as a string. And you could imagine that this might be pumped to another, might be propagated to another function and then another function, and then you find yourself really scratching your head trying to figure out the origin of this bug. All right, here's how we would solve this problem of implicit conversion in Rescript. So in Rescript, as we're decoding the response, we are doing a type check, and if we don't get the value that we expect, we get this error, invalid price, not a valid number. And so instead of propagating the error through implicit conversion down the call stack, we at least get the error right in the decoding process of the price, so much sooner. And so this solves the problem of so you're not catching the problem later down the road, you're catching it right here during the decoding of the response. Let's take a look at a similar example around untyped JavaScript third-party libraries that you may import into your code. So here we have a process input function. It's invoking this untyped third-party library process. The result is clearly what we expect is a number. We add the number plus 10. We get the same type of error as in the previous example. Instead of adding a number and a number, we're concatenating a string and a number, which results in an implicit conversion. And instead of getting 15 as we expect, we get the string 510, and the error is propagated down the call stack, resulting in some type of error further down. Now, here's how you would solve this problem just by choosing another language, ReScript, as in our previous example. If you happen to interact with an untyped object, ReScript requires you to decode it on the spot. So in this case, we get some number or we get none. And in this case, we're setting it to 0. So at least when we're logging to the console, we're adding two numbers. Is this the best way to solve it? I don't know. But what I'm showing to you is that the error is not propagated through implicit conversion. If you're curious about next-gen web dev languages, like, subscribe, and follow me on this journey. Bye now.